All right, let's get right into it. On January 8th, 2026, EASA put out a critical safety directive, PAD 26-001, and this one affects some of the most common engines out there, the CFM56. The big concern here is the risk of an uncontained engine failure. So in this breakdown, we're going to walk through exactly what you need to know and, more importantly, what you need to do. So here's how we're going to tackle this. First, we'll dig into the why, the unsafe condition that started this whole thing. Then we'll nail down exactly who's affected. After that, we'll get into the nitty-gritty of what must be done. And finally, we'll zoom out to look at the bigger impact before wrapping it all up with the key things you need to remember.
Okay, first things first. Let's really get to the bottom of why EASA even issued this directive. It all boils down to one specific and pretty serious unsafe condition.
So what exactly went wrong here? Well, investigators found these cracks on engine seals, and they managed to trace them all back to a single root cause: a faulty repair process. To be specific, the problem was introduced during a honeycomb replacement on these high-pressure turbine seals. That's the source of the whole issue.
And wow, this slide really lays out the whole chain reaction, doesn't it? It's like a domino effect. It all kicks off with that faulty repair we just talked about. Then, while the plane is in the air, a piece of that honeycomb can actually break free. Now that small piece basically becomes a tiny missile inside the engine, flying at high speed and slamming right into the main rotating seal. And that damage? Well, that's the last step right before a potentially catastrophic failure. Yeah, and EASA is definitely not mincing words here. This is a direct quote from the directive itself. When they use a term like uncontained release, what they're really talking about is parts of the engine blasting through the casing at incredibly high speeds. And that, my friends, is a genuine worst-case scenario. It's a direct threat to the plane's most critical systems, not to mention the structure of the aircraft itself.
Okay, so you're probably wondering, is my fleet affected? Let's dig into exactly which engines and aircraft fall under this directive. And yeah, take a look at this list. This is no small thing affecting some obscure fleet. We are talking about the absolute workhorses of modern aviation. You've got the entire Airbus A320 family, the A340, and the incredibly popular Boeing 737 NG series. And it's not just a few of them. All serial numbers of these key CFM56 engine types are potentially affected. All right, this is where the real detective work kicks in, especially for the engineering teams. The directive lays out what it calls an affected part 1. And listen, it's not as simple as just looking at a part number. It's all about the part's history. You literally have to take the serial number and check it against a specific service bulletin to find out if it went through that bad honeycomb repair. And it doesn't stop there. There's a second list you have to check, which defines affected part 2. This one points to a different service bulletin, one related to a one-time Borescope inspection. The big takeaway here is that you can't just check one list and call it a day. An engine status is totally dependent on checking its history against both of these documents. So, all of that record checking leads to this one absolutely critical step. Every single engine has to be sorted into one of 4 groups. Think of this grouping as the master key for compliance. It's based on which affected part might be installed, and it's also combined with the specific front seal part number. If you get the grouping right, you'll know exactly what you need to do. But if you get it wrong, well, you're just not compliant. It's that simple. Okay, let's move on. This next section is really where the rubber meets the road, especially for the technical teams. I'm talking to you, KMO folks, planning, maintenance. This is your playbook. We're going to break down the precise actions and the deadlines you absolutely have to hit. This table is a great summary of the overall game plan, and you can see the logic behind it, right? Group 1A is clearly the highest risk category, so it needs repetitive inspections. Groups 1B and 2, they have different inspection rules based on their specific setups. And then you have Group 3. Those engines are okay for now, but here's the kicker. You are prohibited from installing an affected part on them. It's basically a way to quarantine the problem and stop it from spreading. Now, if your engines fall into Group 1A, this slide is basically your new calendar. And you'll notice the inspection intervals are different. See that? The -5C engine, which you'll usually find on the A340, has a much tighter interval. That's likely because of different operational stresses compared to the -5B and -7B models you see on the A320 and 737. It just goes to show how this directive is really tailored to the specific context of each operation. Okay, so what happens if you actually find something during an inspection? This is absolutely critical. If you find any cracks or damage during a borescope, that aircraft is grounded, period.
You have to contact CFM for instructions before it can fly again. Now, during a shop visit, the process is a bit more structured, but the outcome is the same. Even if you don't see any separation, that faulty honeycomb repair has to be replaced. You've got to eliminate the root cause of the problem.
Okay, for all you operators dealing with those Group 1A engines, here's how you get off the merry-go-round of repetitive inspections. The end game is a full shop visit. Getting the engine into the shop for inspection and correction serves as the terminating action. And here's a super important note for your supply chain and procurement teams. Once these affected parts are removed, they're basically blacklisted. They can't be installed on any engine. Ever. All right, let's pull back from the super technical details for a moment and look at the bigger picture here. How do all these actions actually make flying safer, and what's the real-world operational impact for management?
This slide really puts it all in perspective. On one side, you've got this incredibly severe hazard, an uncontained engine failure. And on the other, you have the safety net that EASA has put in place. It's a proactive strategy, right? The goal is to find and fix the problem with these mandatory inspections before it ever gets the chance to escalate into a full-blown catastrophe. From a manager's perspective, this AD translates into 4 key areas you need to be thinking about. First, there's the downtime risk. A bad finding during a borescope could ground one of your planes without warning. Second, planning. Your engine shop visit schedules now have to build in time for this work. Third, logistics. You've got to make sure you have the right tools, parts, and trained people ready to go. And finally, procurement. Your supply chain needs to be scrubbed clean of these prohibited parts. This isn't just an engineering problem. It touches every single part of your operation. Okay, let's bring it all home. We'll wrap this up with a final summary and a clear call to action for everyone on your team. So let's just boil this all down to the absolute essentials. WHO does this affect anyone operating aircraft with these common CFM56 engines. What do you have to do? Your main job is to figure out the right engine group, then perform the required inspection and any necessary corrections. And when? You have to get all of this done within the very specific deadlines laid out in the directive. No exceptions. The bottom line here is really simple. Full compliance is mandatory. This is not something you can put on the back burner. And it's not just a task for the engineers. It requires a ton of coordination between your camo, planning, maintenance, and even commercial teams to pull this off on time. And please remember, while this explainer is here to help you understand it, the official EASA AD text and the related service bulletins are the only documents you should be using for legal compliance. They are the final word.
Subscribe to AEROPODA YouTube channel.